I've never quite understood why game developers write their own game engines. A couple of days ago that changed because I got to talk to Travis Vroman, who has written several game engines for his company, and I got to ask him some of my most pressing questions. For example, why should you even write one? Is it worth it? Who should do it? And also, if you want to write a game engine, where do you even get started? How long does it take? What are the biggest roadblocks? What can go wrong? I got super fascinating answers, so definitely make sure to stick around if you're interested, that is. Make sure to check out Travis' channel after this video because he has an amazing channel about game development as well. For now, let's start with the question. Travis, why should you ever write your own game engine?
Alright, thanks Jonas. So without further ado, let's get to the questions. The first advantage is that you have full awareness of how everything works under the hood because you are the one that wrote it. So the second point is that you have full control over the architecture, design, and operation of the engine under the hood. You can make all the decisions on how you want the various components to work. You have complete control over how those components get developed and work together, and how the engine ultimately winds up getting used. Another advantage is writing your own game engine can meet the specific needs of your game or project. So sometimes there are specific needs that you may have that no out-of-the-box engine addresses. So let's say, for example, you're making a game that the end-user license agreement either states that you're not allowed to make, or that it's going to be very expensive to make because of licensing. A common example of this would be gambling style games. A lot of game engines have very strict policies on gambling games. They either don't allow the use of the engine to make a gambling game, or instead they charge an astronomical rate to actually use the engine in that manner. There may be other needs too. Maybe there's specific needs on how your engine pulls assets down from the web. Maybe there's some intelligent loading or something that you have to do in order for your game to run the way that it's required by maybe the client or something like that. Maybe you've got special integration points that you need to meet. There's lots of reasons out there why you may need a specific engine for the application that you're writing. The answer there is specific needs of your project or game. So another awesome advantage to writing your own game engine is that it is a huge educational exercise. The amount that you will learn by writing your own game engine is irreplaceable by any other source. When you learn about how to interact with various graphics APIs, such as DirectX or OpenGL or Vulkan or any Metal, whatever other APIs there are out there, you're not going to learn that stuff any other way than actually getting your hands dirty and getting in there into the code and just writing it out. The experience of writing a game engine and failing at writing a game engine, because that's probably going to happen, and the mistakes that you will make writing a game engine are invaluable as learning exercises. From those failures, you can learn, okay, well, I did it this way this time and that didn't work, so I'm not going to do that again. I'm going to try this other way instead. Those learning opportunities are unparalleled by any other means. You're simply not going to learn anywhere near as much just by using an existing game engine versus writing your own. That coupled with the next point, in that you get bragging rights. I mean, this is kind of a big one for many people, is that when you've written your own game engine and it's something that's complete, it's tangible, somebody can go grab a copy of it and start making games with it. It's available online. There's massive bragging rights to be had there. And even if it's not something that has been made publicly available, but perhaps you've made a game engine for a company that you work for, being able to have that on your resume, that you have architected and built a game engine, is huge. It's not something that you see very often, certainly on resumes. It's just an invaluable thing to have, is that experience in doing that professionally.
I understand. Did you know I have 2 backpacks? So for a very long time my point was pretty much, no, you shouldn't write your own game engine. No. It's a waste of time. So I'm curious to hear your take on this. What are actually the disadvantages of writing your own game engine from a professional's perspective? Curious to hear that. Take it away.
So the first disadvantage would be there is a lot of invisible work. And by invisible work, I mean work that has to be done under the hood that you don't necessarily see right away on the screen. It's everything from initializing your graphics API, so initializing OpenGL, initializing DirectX, to work with your operating systems, your target operating system's Windows system. I mean, implementing Vulkan, for example, just to get some boilerplate code, I think takes around 600 lines last time I implemented it from scratch. So, I mean, there's a lot of code that you have to write just to get things sort of up and running, some boilerplate code just to get a window up on the screen and render a triangle, for example. So the next disadvantage is you're focusing more on building an engine than a game. And this may not be a disadvantage depending on how you look at it. If your goal is to make a game, then yes, it's certainly a disadvantage. If your goal is to learn how to make an engine, then it's not really a disadvantage. I figure it is worth mentioning that building a game engine takes your focus away from actually building a game, and you're building the engine to run that game instead. So that can definitely be a disadvantage here. Kind of on that point, it takes a lot more time to make a game. If making a game is your ultimate goal and you're writing your own game engine, it takes a lot more time to actually do that. Sometimes it can actually take multiples of the amount of time that it would have taken you to write the game engine. If your ultimate goal is to write a game, writing a game engine is going to slow that down because you're going to have to write all this tech to then write your game on top of that tech. So it's definitely something to consider as well. So the next point is that you are basically your own support system, your own documentation generator, and so forth. So what I mean by this is a lot of the big box game engines like Unity and Unreal have a plethora of tutorials and online resources, forums, documentation, both for code and engine features, and editor features and things like that. All of these things which are specific to the engine that you're not going to have for your engine to sort of back you up. So everything's got to be kept up here. And if this is an engine that you're considering releasing to the public, these are all things that you're going to have to document. It's not necessarily something that you see on the screen as progress with your game engine or the work that you're doing, but it's all work that has to be done nonetheless. If you're trying to create a game, it's going to slow you down that much. All right, so the next big piece of this, and this is something that I feel often gets overlooked, is you have to develop your own toolchain from scratch.
I don't want to do this, I'm out of here.
So any editors that you need, visual editors like level editors, graphic user interface editors, asset importers or converters, anything that you need to sort of help you along with developing your game, all the tools that you're going to need to support that process. In fact, the build process for your game engine is another thing, because you're going to have your engine and then you're going to have your game, and those two things are very separate, and most of the time your engine will actually be referenced by your game, and so you need to set up a process that connects those two things together and makes that happen. And depending on the architecture of your setup, that can get very complicated over time. So it's definitely something to be aware of. The final point that I'm going to list here as a disadvantage, and by no means is this an exhaustive list of each, is the opportunity for failure. When you're developing your own engine, the most common thing that happens out there, some design decision that you made way back winds up coming and completely screwing you over. And it's something that sometimes you can recover from, sometimes it takes a lot of refactoring to actually recover from that, and sometimes it's a fatal flaw in the actual design of your engine, and it's not something you can overcome, and you've got to throw the whole thing away and start over. Or it would take longer for you to fix that thing than it would be to just start a new engine. The opportunity for failure is very, very high. That's why there's not a lot of game engines out there, or not a lot of successful game engines anyway. And that's because game engines are super complicated things, and they have a lot of moving parts, and there's a lot of things that are changing along with technology that's constantly changing. And those are all things that you have to worry about when you're developing your own engine, where if you're using a out-of-the-box engine, all those things are taken care of under the hood, abstracted away for you. It's definitely something to be aware of, and sort of on that point is also hardware support, which can also trip you up a lot of times. It's sort of an additional bonus point there. But yeah, those are really the disadvantages to writing your own game engine.
How long would it even take me to write a game engine? I mean, how much work is that?
So the answer to this is variable. It highly depends on what you want your engine to do. Is it 2D only, or is it 3D only? Or is it 2D and 3D? Does it have networking? Does it require multiplayer? Or is it just single player type games only? That in and of itself is a massive difference between the two. Networking layers can sometimes take months or years to even perfect, especially if you're trying to build an engine that is capable of supporting many players at the same time, all running around in the world together and interacting with one another. The networking layer can be one of the most complicated things that you can actually run into. Also, is there a physics engine? If there's a physics engine, are you going to use an out-of-the-box one, or are you going to write your own? Either way, you're going to either have to tie in that existing library, or you're going to have to figure out how to write your own. These days, I don't think many people write their own physics engines anymore. There's not really a need. There's plenty of ones that work very well out of the box. There's Bullet. There's NVIDIA's physics, just to name a couple. And there's a lot of these libraries floating around out there that are really good that there's not really a need to write your own anymore. But if you do decide to write your own, you're going to have to deal with all the bugs that are going to come up with that, and all of the implementation details, and that can take a really long time. Just like the networking, it can take months or years to perfect your physics system. One final point that I want to bring up here is implementing your own animation system is one of the most complicated things in making your own game engine, and can greatly increase the amount of time that it takes to make your engine. Now, if you have a super basic 2D engine that only supports animation through animated sprites, that's pretty straightforward. It's not going to affect your overall time very much. But if you're writing a 3D engine that supports skinned 3D meshes and animations, and then you've got to worry about bones, you've got to worry about weights and transforms and all that, and that gets super complicated really quickly, and it's very error prone, and it's one of the hardest things that I've run into when making engines, and it can increase the amount of time that it takes to make the engine greatly. So as you can see by some of the information that I'm providing here, there's no one answer on how long it takes to make a game engine. It really depends on what features you want in your game engine, and it depends on how far you're willing to go with those features, and how many features you're willing to add, and where the cutoff point is. And it greatly depends on the complexity of the features that you want to add. So yeah, there's not really one answer to that question, unfortunately.
So now we've already heard so many things that are difficult about writing your own game engine. Physics, multiplayer, writing your own documentation, writing your own import processes. All of that sounds super annoying and super difficult. So my question to you, Travis, what is actually the most difficult part about writing your own game engine? What are the biggest roadblocks? Really curious to hear your professional opinion.
Honestly, there is one answer to this, and it's motivation. Motivation to stay in it to the end. Game engines are one of the hardest things to develop, especially if you're doing it on your own. There are so many different pieces that go to a game engine that it's really complex to tie all these different systems together and make them work cohesively. People can get overwhelmed by the amount of work that has to be done. It takes a lot of dedication and a lot of time to get all those things done. It is one of the hardest things that you can program out there as a game engine. I'm not necessarily saying that nobody should try to develop a game engine, but it does need to be recognized that the hardest part of writing a game engine is staying motivated to actually finish it.
Yeah, finishing is always the hardest part, so one more reason why writing game engines is not for me. So my next question, who should write their own game engine?
I'm actually going to modify this question. Who should write it and who should not? There are two types of people that should write their own game engine. The first type is the type that wants to go into game engine development as a career. It's for those out there who want to make game engines for a living. They're not really interested in making the end product of the game as much. They're interested in actually building the tech that makes the games. It would be like working at Epic to work on the Unreal Engine, for example. The second type would be somebody who's in it for the educational experience. And that tends to fall under the category of hobbyists more. A lot of hobbyists like to write their own game engines. I think that is fantastic, and I think that if you have the willingness to stick with it until the end, it's absolutely something that you should do. It is a fantastic learning experience. On the flip side of that, who should not write their own game engine? That's typically people who want to focus on the game development side of it, the actual making of the game. Game designers, people who like the creative aspect of it, or who like the, prefer the level design, or the character design, or the story, or the sound, or the music, or any of these other aspects of game development. People who just want to make games and publish them shouldn't focus on engine development as much. If you're looking to pump out games, game engine development probably isn't for you. And that's okay, there's nothing wrong with that. If you are not a programmer with a lot of experience, game engines is probably not where you should start. With that, I think I'll just leave that point there, but I just kind of wanted to bring that up as an additional bonus answer to that question.
Let's assume you want to write your own game engine. Where do you start? What are the first steps you need to take?
The first part of this answer is relatively simple. Look at existing game engines. Look at engines that are out on the market. Get an understanding of how those engines work on the top end. Understand how to use the tool sets, how to use the editors, how they work differently from one another. Realize what you like, what you don't like, what works for you and what doesn't work for you, and then move on to the design phase. It becomes more practical at that point. It becomes sort of a step. And this is by no means the complete process, but I'm going to give a brief overview of the sort of process that is generally followed when developing game engines. So the first step is, of course, bootstrapping. And what that means is you get your basic systems in place, like your ability to open a window in the operating system. Logging. Logging is super important for troubleshooting, especially in real-time games. Also, file system access, reading and writing files. It seems like a basic thing, but it's something that you want to get in your engine and get abstracted as soon as possible, so that you can call your own methods to open files. All right, so the next portion of this is a bit variable. If you're working on an engine that's going to support multiplayer, the very next thing you need to do is your networking layer. You need to do it early, because if you leave it till later, chances are you're not going to design something correctly in your system having that in mind. So the very next thing you need to do is set up your client and your server and get the communication between those two working. Even if it's just sending text packets back and forth through TCP or UDP, whichever you choose. Usually it's a combination of both. Get that set up as soon as possible if you're supporting multiplayer. If you're not supporting multiplayer, then you can completely skip that step. So the next layer is generally the graphics API. So this is where a lot of tutorials tend to start off, and I think this is a mistake. I think that there should be some groundwork laid before this, but this is the interacting, or I should say the initialization and then the interaction with your OpenGL or your DirectX or your Vulkan or Metal or whatever it is that you're using. This is where you start to see things happen on the screen. It might be basic things, it might be rendering a triangle or whatever, but this is sort of the next place that you start is getting your graphics API all set up and get that abstracted away as soon as possible. The next thing is a basic asset pipeline. So you want to define and design your pipeline, determine how your assets are going to be imported just on a high level, and sort of design some of those interfaces for that. The next thing is how you're going to handle game screens UI interaction. That generally is the next step. After that is the world and scene graph. And the reason that comes after is actually because it's more important to be able to interact with your engine and be able to click things or type something and be able to provide input into your engine so that you can actually test what you're doing in the world. So that way when you create your world and your scene graph and your camera, you don't have to worry about then going back and implementing input. You can just tie in your camera to input and you're good to go. The next part of this is if you're doing multiplayer, you need to implement object state for client and server. So in other words, if an object moves from point A to point B and you need all clients to be able to see that communication, how that happens in your networking layer needs to be defined and set up now before you get anything too fancy done. Because the longer you wait, the harder that's going to be in the future. Next, if your engine uses physics, this would be the time to actually set that up before you get too many crazy features in. And the next step after that is obviously if you have multiplayer support, you would then need to figure out how to treat those physics over the network. So generally speaking, you might send positional and rotational data over the network, and then when your client receives that type of data, your physics engine would start processing from that point and do something with it and send an update back. And so you have to figure out how to make those two things interact with one another without stepping on each other's toes as far as what updates happen when, how often something should update from the network, and how often the physics system should actually be updating something. That can be a very tricky thing to figure out, and the earlier you figure it out, the better. So finally is tools. So this is like your level editor, your asset importers, maybe with a graphical interface so you don't have to do everything command line. It's just basically any tools that you need in order to be able to make content for your engine.
Okay, all of that sounds pretty awesome and straightforward, but I think there are probably a lot of complications when you actually try to do this. So where can you learn how to write your own game engine?
The answer to this is a collection of places. First off, gamedev.net is a huge resource. It's a resource that I've hit too many times to count over the years, and honestly the people there are super helpful, as long as you do your homework before asking a question. You know, if you go in there and just expect them to guide you through every single step of the process, you're probably not going to get all that much help there, because they're there to help you, not do it for you. You know, over the years I have had a lot of good experience with that as a resource. Also, there's Stack Overflow, which is super useful. Another one I found is learnopengl.com. And of course, YouTube videos. YouTube videos are probably the biggest resource on learning how to write a game engine. BennyBox has a bunch of stuff out there on writing OpenGL game engines.
Travis, next question. Which tools and which programming language would you recommend for writing your own game engine?
First off, the answer to this completely depends on platform and your target audience. If you're going multi-platform, one of the easiest ways, at least for 2D engines or simple type games, as long as it's nothing too complicated, I like the HTML5, JavaScript, TypeScript, WebGL tech stack, because you can wrap it in Apache Cordova, or you can use Electron, or you can use Cocoon, which is another system which is freaking awesome. You can basically wrap that page in an application and have an app that runs on mobile devices as well as desktop, or PC or Mac, and it's very flexible, and because it's WebGL, it works basically the same way across a whole bunch of devices. I've found it to be very powerful and excellent, as long as you're not making a game that is super graphic intensive. If it's graphically intensive or requires a lot of physics or things like that, that's probably not going to be the way you're going to want to go. But then again, you're probably also going to have a more specific target platform if you're doing something like that. So with that in mind, if you're targeting PC or Mac desktops only, C++ and OpenGL all the way, because OpenGL is cross-platform. There's tons of documentation on it. There's tons of documentation on C++. It's the industry standard for writing game engines on those platforms. So it's definitely the way you should go as far as that's concerned. If you're doing Windows PC and Xbox only, C++ and DirectX is usually the way to go as far as those two are concerned, because DirectX, of course, is Windows and Xbox only, and it's an awesome API. I wish it was cross-platform, because it really is a nice API to work with, but unfortunately it's Windows only. So if Windows is all you care about, and you don't care about any other platform, then definitely go DirectX. And as far as the tool chain, I use Visual Studio for all of those things because I prefer it. It's a nice environment to work in. The IntelliSense is great in it, and the build process and tool chain is very nice to work with. So the debugging tools are also very powerful in it. So I tend to lean more towards Visual Studio, no matter what platform I'm targeting, unless I'm doing my development directly in a Linux box. Then I might use code blocks or something like that, but usually Visual Studio is my go-to. So that pretty much wraps it up for the questions. I will turn this back over to Jonas.
Thanks, Travis, for answering all of those questions. Definitely check out Travis' channel. He makes awesome videos. I recommend you check out this one. If you don't want to see that for some reason, then click on his channel here and find something you want to watch. Yeah, hope you enjoyed, hope you learned something, and see you in the next one. Bye!